present in the field of the ring, or the ring present in the field of the rod. I'll give the both approaches. So there's a ring. This is a rod having mass m. There's a lambda. So what you can assume is like, assume a small element dx. It will have mass dm. So what is the field? The field will be like this, no? E bar. This is due to what? Let me call this is 1. This one. E1 will be like this. So this will experience a force. So we know what is E1. E1 is equal to gmx by r square plus x square to the power of 3 by 2. Can you remember? And what is x? X is the element. Then what is the force acting on it? df1 or df, you can write. This should be equal to dm into E1. dm2 you write it if you want. So what is dm2? Lambda into dx. This E1. Then integrate this from 0 to infinity. This is x equals 0. This end is infinity. Integrating 0 to infinity will get the force of interaction. This is the mathematics. Huh? If you are very good in integration, yes, you can have this approach. Without integration also you can do it. So what I assumed here, the rod is present in the field of the ring. Then where it is on the axis, the rod is on the axis. What is the gravitational friction on the axis of the ring? This is a formula. So what is the field? Field is uniform. So therefore I'll assume a small element. Then what is the force explained by small element? Then I'll integrate from 0 to infinity. I'll get the total force. How to do like the ring in the field of the rod? So you go back to the rod. Rod is having two fields, no? If you look at the rod, okay, if you can recollect here, at the location of the ring, this one. So let me, there's a ring. I think there's a diagram what I can show it here, no? Tell me how the E bar is the location of the ring. It will have two components, no? One will be E perpendicular. The other will be E parallel. Not only here, everywhere at all points, this would be the condition. Due to what? Due to the rod. So we know this one. So this is actually, if you look at the ring, so what are the forces the ring will experience? The ring, what will happen? If you look at the forces here, everywhere E parallel will be like this. Not at 2 points. E parallel will be acting at all points. Huh? In this diagram, I'm able to show only at 2 points here. So this is the thing. So where is the rod? Rod is here. I'll magnify the. So it's all about the student's imagination, huh? Because beyond this, as a teacher, okay, fine. So this end is infinity and this is a rod. It will produce E parallel everywhere. What about E perpendicular? How E perpendicular? E perpendicular will be perpendicular to the rod everywhere. Everywhere it will be acting that one. So you go for one more diagram. You go for one more diagram. So if you want to show only E perpendicular, No. How the E perpendicular will act? E perpendicular will be acting towards center, no? Everywhere it will be directed like this. I'm showing at all points it will act. I'm just showing only at few points. And what is the radius? The radius of this is R. That's what given for us. I think now you have enough idea. What will be the net force on the ring due to E perpendicular? Will be zero, no? You assume this element. This element in what direction will expend force? In this direction. What about this element? Will be in this direction. So what is the net force? Will be zero, no? Like that, due to E perpendicular, the net force acting on the ring will be zero. But E parallel, it will get added up. You take small element of mass in dm. Then what is the force on this? Let it be df. So what is the df is equal to E parallel into dm. dm1. Okay, if you want to write dm1. What is E parallel? Anybody formula E parallel? G lambda r. Agree this? Instead of small d, what happen here? R will come into picture. G lambda r. Both E perpendicular, E parallel, how much value will be? G lambda r. And then what is dm? Dm is the mass, that one. So I'll integrate this. I'll integrate. G lambda r is a constant, come outside. What is the total mass of the ring? It is equal to m. Is this okay formula? E parallel, E perpendicular. If you don't know this, then gone. Nobody can help you. Or else you have to go back to the formula. Semi-infinite rod. What are the components? Parallel component and perpendicular component. From that, what happened? You should get that one. Okay, fine. This is the just see once. I'll scroll down. Now, small objective. Suppose say if it is a I'll ask it here only. If it is a ring like this, and if this is a rod, are you trying to see the rod will pass through the ring along the axis? The rod is kept. Why it is not coming? No, you see this. This is m. Let me write lambda 1. This lambda 2. This is the radius r. What is the force of interaction? You know, in this case, will be zero, no? So what force the right hand side? It's a long rod. This is a long rod. Long rod lying along the axis of the ring. What force this rod will experience? The same force this rod will experience. This half of the part. It's a long rod. Or you can break it up to semi-infinite long rods here. I think I had to show like this only. The long rod lying along the axis of the ring. What force this will expend? This rod, this half of the rod will expend force towards left. This half of the rod will expend force towards right, and the net force will be zero. So what is the force of interaction here? In this case, it will be zero. The objective questions can be tested. You should be very careful. No force of interaction, or you can assume that a ring present in the field of the rod. Then due to this, E parallel will be like this. And due to this rod, E parallel will be like this. Net force on the ring will be zero. I'm just picking up questions very randomly, not in order.